Assalamu alaikum students. Our today's lecture of industrial electronics is about electric heating in industries and different household applications. Uh, about its introduction, we will talk about that electric heating is extensively used both for domestic and industrial purpose. In different industrial applications, electric heating is used as well as in home appliances, which is also used. It's if we say that domestic application includes room heaters, immersion heaters for water heating, and hot plates for cooking, electric kettles, electric irons, popcorn plants, electric ovens for bakeries and cooking purposes, and electric toasters, etc. These are the typical applications, you can say domestic applications, which are widely used in our um, surroundings and also in homes, we can say. And if we compare the different methods of heating which are used and different methods which consume gas and coals and different fire, fire burning things, etc. Like that. Electric heating is much more better and superior for different reasons, and it causes low pollution, and we can say that it provides different and for example, if we say industrial applications, which includes fire, as it's also used in industrial applications, and some of industrial applications are listed here as, for example, if we say metal, melting of metals, heat treatment of metals, and like annealing, tempering, soldering, glazing, etc., molding of glass, baking of insulators, and enameling of copper wires, etc. And industrial applications also include that, for example, molding and packaging of machines and packaging of different heatable items, etc. And if we talk about the advantages of electric heating, it provides, we can say, uh, cleanliness, cleanliness as we say that the dust for using the electric heating method, it neither produces any kind of dust nor ash is produced in electric heating. It is a clean system of heating requiring minimum cost of cleaning. Moreover, the material to be heated does not get contaminated. Cleanliness is one of the advantages. Minimum heating is required. Cost of cleaning is also minimum, uh, and no pollution is produced. No flue gases are produced in electric heating. No provision has to be made for their exits, as there is no kind of pollution is produced in electric heating. And economical, this is an economical process, and because electric furnaces are cheaper in their initial cost as well as maintenance cost is also as low as possible, and it does not require any big space for installation or for storage of coal or wood. Moreover, there is no need to construct any chimney or to provide extra heat installation are not needed. And it's ease of control. It is easy to control the electric heating process and regulate the temperature of an electric furnace with the help of manual or automatic devices. Um, and this temperature can be controlled within a given range, which we can say plus minus 5 degrees centigrade, and which is not possible for any other method of heating. And next we say special heating requirement, such as we say uniform heating of a material or heating one particular portion of the job without affecting its other parts, or heating with no oxidation can be met only by using the process of electric heating. And it's we can say it's a controlled technique of heating, and it provides a high efficiency process, and produces electric heating, and does not go away any waste through the chimney, and other byproducts are not the part of this process. If we say most of the heat produced is utilized for heating the material itself. Hence, electric heating, we can say, is higher efficient as compared to other types of heating. As we can say, the heat generated by using the method of electric heating, and all the heat is used for the purpose of is completely utilized, so it improves the efficiency of the system, better working conditions, and we say that electric heating produces no irritating noises, or we also say that no, also the radiation losses are low. It also results in low ambient temperature. Hence, working with electric furnace is convenient and good as compared to different other methods of heating with coal and woods, etc. If we say heating of bad conductors, or we say electricity like wood, plastic, and bakery items can be uniformly and suitably heated with electric heating process, as compared to other methods of by using coal and other typical methods. So bad conductors of heat and electricity are is a best way of heating of bad conductors. Safety is a high priority item, and the electric heating process provides a much more safer, and because it responds quickly to the controlled signals, lower tension and maintenance cost in the process of electric heating equipment, and it's a process requires low maintenance and low attention, low supervision, as it requires also minimum cost of maintenance, which is also almost negligible, and labor charges are also negligibly small, as low as possible as compared to other forms of the heating processes. Um, So these were the different advantages of a electric heating method, and if we say that different methods of there are different methods of heat transfer which are used to transfer heat from a hot body to a cold body. And so we in this here we will discuss one of them is the process of conduction. In the process of conduction mode, in the mode of heat transfer, we say that when one molecule of the body gets heated and transfers some of the, we say its energy, heat to the adjacent molecules, and so on. This process goes on and produces the required amount of heated. There is a we are temperature gradient between the two ends of the body being heated. Which body is we are going to heat? There will be a temperature gradient between the cold and hot parts. If we consider a solid material of cross-sectional area A square meter and thickness of if we say x meters, as shown in this figure, if T1 and T2 are the temperatures of the two sides of the slab in degree Kelvin, then heat conducted between the two opposite faces in T times is given by this formula, according to which the heat transfer is equal to Ka T1 minus T2 into T a second of time per X, where K is the capital K is used is the thermal conductivity of the material of which this slab is made of. So the heat conduction process is described by this figure. When one molecule is heated, it transfers the heat to the next molecule, and when that heated completely, it started heating the next molecule, and so on. With the passage of time, all the molecules are heated and transfers the heat to the next portion, and similarly, by conduction, stoves are also now are used in the markets to use this technique of conduction heating method. Uh, Next is we can say the process of convection process of heating. In this process, we say heat is transferred by the flow of hot and cold air currents. Again, hot and cold air currents are used to heat up different materials, metals, liquids. This process is applied in the heating of water by immersion heater or heating of buildings. Is also used in the heating process of convection. The quantity of heat absorbed by the body by convection process depends mainly on the temperature of the heating element above the surroundings and upon the size of the surface of the heater. It also depends to some extent on the position of the heater, that at which state or which distance heater is placed. The amount of heat dissipated, we say, is given by this formula, which is equal to A into T1 minus T2, where A, B are the constants and T1, T2 are the temperatures of the heating surface and the fluid in degree Kelvin centigrade respectively. In electric furnaces, heat transferred by convection is negligible, and we say that electric furnaces there is also a heat which is we say transferred by the process of convection. We say that heat is negligible as it is very low in very low quantity. Okay, next process of electric heating is the process of radiation. And in this process of radiation, the heat is transferred from a hot body to a cold body in a straight line without affecting the intervening medium. That heat is transferred in a straight line without intervening the medium. The rate of heat emission is, we say, given by the formula of Stephen's law, according to which dissipated heat is equal to here we say H is equal to 5.72 E K T1 by 100 is about 4 minus T2 by 100 is about 4 uh, watt per meter square, where K is the radiating efficiency and E is known as the emissivity of the heating element. That heat, how much heat is emitted from that element. If D is the we say diameter of the heating wire and L its total length, then its surface area from which heat is radiated will be equal to pi cross D cross L. And if we say H is the power radiated per meter square, heat is the power radiated per meter square of the heating surface, then total power radiated as heat will be equal to H cross pi dl. If P is the electrical power input to the heating element, then P will be equal to in this formula pi dl cross H. These were the few methods which are used as electric heating methods, and and there are different methods we say which are used in these processes, and we will discuss those methods in our next lecture, and we say those methods and which will include the methods of electric heating, electric that which medium are used, and resistive heating, and different methods will be discussed in our next lecture. Take care, students. Allah Hafiz. Assalamu alaikum.